Okay, today we got a problem. That's gonna be from some recent contest, so some garbage. Concatenate non-zero digits and multiply by sum 2. You are given a string S consisting of m digits. Oh no. You are given two queries. Extract substring form by concatenate non-zero digits. The answer is x times what the hell? What the hell? Return an array of integers. Return an array of... Okay, so we... I knew this will be a dog water shit. So you multiply the actual number you form. 0, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4 times the sum, which is 10. So yeah, 1240, then 1 3. So to all my days. How long is the string? Fair enough. Expected queries 10 to 5. Oh, I mean, okay, sum we can do like prefix sums, so that's easy. Now problem is, how do we do like I think that should be easy too, because let's say we want to know what is this number, right? This whole like we want to know this whole thing, and we know this and we know this, right? And we want to know this suffix. Well, it's this prefix shifted by a lot to left, right? And it's the entire thing minus this prefix shifted by whatever the number of digits is here, which you should be able to calculate. So if we use like binary exponentiation, we should do that quite easily. So that's just some garbage prefix sum problem. Okay, whatever. So let's grab the length of the string. And now let's do like a prefix for I in range n plus 1, for I in range 1 n plus 1, pi equals pi minus 1, plus ordin, so this converts char into its int code, so technically just int conversion, and we want to subtract from it the char of 0. Or do we want to do this? S is list S, pi is pi minus 1 plus si minus 1, list map int S, list S, like that should work. Okay, that's fair. So now we got that, and okay, we need modulo. What we want to do, we need these prefixes, right? Because we will need some substring. So Okay, so we need to compute these prefixes. So let's call this like p prefix, so sum is sum, so px, because the x is the constructed number, so range, and let's call it n plus 1, and do like for I in range 1 n plus 1, we can do it here also. And now how to do that? Well, if si minus 1 over 0, then px, pxi is equal to px, is 0, then pxi, px I minus 1, else pxi is pxi minus 1 times 10 plus si minus 1, whatever. Let's see what's px outputting. 0, 1, 1, 2, 1, 2, 4. Okay, so we got some numbers, and important thing, pi percentage mod and pxi percentage mod. Great, so we got that. And now I guess we answer the queries. So lr in queries. Now if that's including, so if pref r plus 1 minus pref, I don't know why I used p when I'm used to pref, but whatever, is 0, ans append 0, or I think it's like that, enumerate queries. The reason I'm doing this, that I want to pre-allocate space for the answers. And queries, to not mix it up, so we can skip because the answer is already set to 0. Now, because like the numbers in there, their sum is 0, so it's already 0, and the number is either way 0. So now we also return ans. Great. Now we are here, and let's add some spacing, because why not? And whatever, let's do that. And then this. Okay, so what we want to construct is the actual number. So digit sum is just could be digits. Now let's say, so this can be 0, and this could be 10 to 9 plus 6. So if I subtract it, then I have to add 1. So here is what we do. So we add 1 modulo, so that we avoid underflow, and then we modulo it. You know, worst case, this will be 10 to 9 6, 10 to 9 plus 6, and this will be 0, so we will get like 2 times 10 to 9 plus 13, and modulo will still get us the same answer. Alright, but solves underflow, so we got digit sum. We also need the x itself. Now, how did I say that we're gonna construct that? Well, we take the, let's say we have a query of 1 3, right? I probably should have some prefix for zeros, because I want to know by how many digits I have to shift it. Okay, that's like P0. We can just P0i minus 1 plus s plus not si minus 1, who cares? Or that's not how that works, but let's do it here. Great. So we got digit sum, we now want number sum. Well, how do we get that? We get this sum, right? There is a little problem with that, I think. It will not work. If I take these suffixes, the less interesting part goes out, but suddenly moving that changes the modulo entirely, so this approach won't work. Okay, that sucks. Okay, because the module is bad, I think, because like let's say I have, like I cut off this part and it's 12, it doesn't matter, but what if it's like 10 to 9 plus 10, right? This will have a sum of 3, right? But suddenly with this it will have it will 3 0, it will have like or another 10 to 9 plus 7, right? When I add that, suddenly it should be 0, which doesn't matter. Let's say there will be 5. So if there is 5 and this remains 3 and we just shift it out, that gets to be 35, but the real modulo is like not good. Okay, that's not great. Okay, there is one technique I can think of for solving problems with queries, which is most algorithm, but that's disgusting. Like I would break the input string into sizes of square root, and I would compute the answer for each of them, right? So I would compute the number, compute sum of digits, and now when a query comes in, I can join those blocks in O1. That's no problem, right? But again, the modulo thing becomes a problem, so I'm not sure how to solve that. Because still it's a problem, because let's say I have a number, and now let's say I take like, so it consists of 1, 2, 3, 4, 5, 6, 7, 8, 9. So it consists of this part. Let's do one here. So it consists of this part, right? So that's boom, 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 times 2, 3, 4, 5, 6, 7, 8. Wait, does it matter? 1, 2, 3. So times 10 to 8, or let's do 10 to 8 like this, plus 1, 2, 2, 3, 4, 5, 6, 7. And now this whole thing modulo, right? This whole thing modulo, we want, that's gonna be our number, right? Now, modulo of plus is just modulo of this, and modulo of this, right? And modulo of this is just modulo of this, so okay, that should work, I guess. I could have done the math sooner. Anyways, so the trick is that sometimes we might have to shift by a lot, but we are doing modulo 10 to 9. So as you saw the times 10 to 8, sometimes we might do times 10 to 1000 or 100,000. And that's bad, because if we get to do that every query, we are cooked. But we don't care about shifting it to 10,000 digits left. We only care about few, because we are gonna either way modulo it, right? So first we get the shift, right? Now the shift is length of the query. So length is equal to r minus l plus 1. Then length, let's do this, not writing two separate lines, a percentage like 11, right? And then we want to do, so let's call x, so let's start with x being px of l times 10 to length, plus, that's starting to get a little complicated, so first part is this, second part is pxr plus 1. Oh wait, is it really though? No, I just want to subtract that number, and subtracting modulo, that's a little more difficult. That does not have to necessarily work. So maybe suffix will be smarter. Because with suffix, if you want to know that, you subtract what? This from that. That sounds smarter, but I guess modulo won't break anything. Who cares? So that's second part. No, that's what we want to subtract. So this is what we care about. And now we want to do x is equal to second part minus first part. We do the same trick, plus modulo percentage modulo for subtraction, ans I is equal to x times digit sum. Let's go. Okay, it didn't work. That's okay. Maybe this will work. Oh sheesh. Yeah, that's bad. Okay. Phew. Okay. Okay. Digits I will not skip, so let's print length first part, second part. So for second query we get, wait, that's kind of, so it's length of this minus, so that's a length, and now digits is length minus p0 r plus 1 minus p0 l, I think, and then this is digits, length digits. Okay, so now just the last didn't work. Oh, okay. So up to here. Sum of digits is like 55 or something. I'm not using modulo here. Dummy. Okay, that should work because modulo, whatever. Let's go. What, 74 cases? Are you shitting me? Why is there a 0.0 in my output? What the hell? Oh, wait. Ooh. Hold up, brother, hold up. What the hell? What the hell is that? My bruh. Why is there a 0.0 in there? 6, 7, 8. So wait. 3, 4, 5, 6, 7, 0, 10. That's weird. Okay. Print px p0. Okay, all are normal numbers, so I'm not sure what happened there. Print x digit sum. That's weird. Oh, whoa. Why is first part? Okay, what's pxl? 0. Okay, that's weird. That's just weird. If I do this, maybe because digits is 0. Anyways. Okay. What? Bruh. 79. My math is not mathing. SMH my head. I don't want to rewrite everything into suffixes. Oh my days, bro. Oh my days. Suffix, 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 suffix. Oh, and we want to go from a range like that, and we do this, and then this, and then this. Okay, boom, 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 like that. Seems fair. And okay, so we do queries. Now, how to get digit sum from L to R? Well, I get suffix of suffix of L, and I subtract suffix of R plus 1. Okay, simple enough. And we get suffix of question is, do we need that? So if we take this whole number, the whole is 11-digit number, so we take suffix and it's 0, so that's just suffix R plus 1, and then suffix okay, and this is, you want to subtract the whole suffix. So from second part is just suffix of L, I think, and then we want to subtract suffix L. Okay, could work, not sure. I don't need digits and probably not even length. These numbers are wrong. This should be 3 how do I... Well, I need to get the strlen and that sucks. So suffix e is equal to int of string of si plus string of suffix I plus 1. I don't care. This is Python S way maximum level. Print suffix. One, two, three. What the freak? If suffix e, no, if si 0, else this. No, if so 0, 1, 2, 3, right? So what are we working here? If print suffix l, print suffix r plus 1, maybe. So from 2, 3, 4 we subtract 3, 4 and how did you end up with 400, bruh? What the hell? Oh. Well, if I have a number that's 10 and then I have like 1,000,010. Brother. Okay, so percentage mod, and then that should be like int string. Okay, so trim zeros is len str suffix r plus 1, and then we do that will exclude last, and we want to exclude last zeros. Zero. Oh, okay. Str ans if str ans int str ans unmatch nothing. Wow, completely terribly, absolutely wrong. Oh, now I'm missing a number. What the freak, man? Now I'm just supposed to pull it out of my ass. So I sometimes cut one too many digits. That's awesome. At least let's have this test case and let's see what will be the 55726 whatever. So Oh, that is completely wrong, dude. Okay, I think I need a hint. Okay, I figured it. Okay, I figured it. Okay, I figured it. So, what? But I already had that. It was wrong. Something gotta be wrong, bro. Maybe this. Didn't help. Only Python can handle these large digits. I mean, that improves the answer, but that probably cannot handle it. Are you kidding? What the freak? Okay. What if I just do this? Now it deal is. Actually wrong answer? No, time limit exceeded. Okay. Well, if I have a number, so from that I wanna subtract that, so I modulo the prefix. Okay, I think I got it. So I got a prefix, and then I got the times exp 10 to digits, whatever, and then let's do like def exp self x, and that's like so that's power, and now result is 0, and now while power is positive, then we do this. So if power is that, then we do result is result times, maybe that's 1, result times x percentage mod, otherwise yeah, I had a mistake in this calculation, I think. Now this is gonna take 1 million years or what? Time limit exceeded. Okay, that should be fast. Okay, not sure why it's so slow, but I think that's optimal, so who cares. So prefix sums, first we need to answer queries for non-zero digit sums, which we can do by using prefix sums. Support queries of calculating the value of non-zero digit of substring the value of concatenation of non-zero integers in a substring, for which we can also use a sort of prefix sums. Okay, so how to do that? To calculate the second prefix sum, prefix sum, suppose we want to calculate the number represented by each prefix. Can we use it is easy to see that the answer for the next prefix is 10 times is old prefix times 10 plus current digit if current digit is not 0. Else it is the for new prefix is old prefix. Now how to get the number of a substring. Let's say we have s equal to and q and query, I don't know, 0, 7, or like, I don't know, 5, 7, 6, 9, 6, 9. Okay, and now what we want to do with this? Let's call this prefix sum px. Can we construct 1, 2, 3, 4, 5, 6, so 2, 4, 6 using and 1 px 6 equal to this, and px 9 plus 1 equal to, okay, of course we just subtract px6 from px10, of course it's px10 minus px6 times 10 to 3. Where did the 3 come from? It's the length of the query. 6, 7, 8, no. Length of the query is 4. Now remember, now problem is we do all this modulo. Will the number be the same? We want so what do we want? Well, note that we have both, note that we calculate both prefix sums modulo 10 to 9 plus 7, but we also first have to calculate 10 to 4, then 10 to 9 plus 7. The problem is that the length of the length of the query subarray can be up to n, and the multiplication would be slow. Therefore we cannot represent 10 to length as an integer, but if we use binary multiplication modulo mod or modulo 10 to 9 plus 7, we can go around this. So first we do pre-processing, and then we do q times log n, I think, since we first calculate the prefix sums in O. Note that to know the shifts, oh my days, what the hell. Note that to know the shift length of the number for the substring query, we have to also have a prefix sum over zeros to subtract their count in the substring from the length of the substring. Okay, prefix sums in ON, and then for each query we do O1 calculations except the binary multiplication, which takes all of log n. Okay, space complexity is ON since we store multiple prefix sums. Okay, I wanna go sleep. Goodbye.